Hi everyone. Hello. Hi everyone in the room and hi everyone online. People in the room are just grabbing a bit of food. Ron, I can see you on the screen. Can you still hear us okay? Thumbs up if you can hear us, Ron.
Can you hear us, Ron? Yeah.
Thank you. Okay, excellent. Thank you very much for coming. It's my pleasure to introduce Kelly Munkittrick, who's here today to give us a GWI seminar. Thank you to Ginger and Greg for arranging the room and the lovely food. I've had the pleasure of knowing Kelly since 2008, when you were the chair of the Canadian Water Network. We've done work in many different places together. Kelly was saying today he's published on every continent, including Antarctica, except Australia. So there's a gap there if anyone picks up something that interests them at the moment. And Kelly is currently the chair in ecosystem health assessment based at the University of Calgary. And it's some really interesting and really big work there in environmental monitoring that he's going to speak about today. Please do eat as we go through the seminar, and then after the seminar, for those that have been invited or interested, he's going to talk about some of the work he's been doing with Indigenous communities here in Australia and in Canada. So I'll get the screen ready and hand over to you.
Okay. I apologize. I have a bit of a cold. The person beside me on the flight on the way over coughed the entire flight and didn't wear a mask. And I want to get her address so that I can send her a thank you. And thanks to Danzy and Ginger for arranging this. I'm going to talk a little bit about a program I developed when I was working in industry on integrated watershed management, which I affectionately call Kelly's theory of everything. How do I go down here? Okay. So I've had a varied research background. I worked 4 years in private industry before moving to the federal government in Canada. I worked 6 years for Fisheries and Oceans, 5 years for Environment Canada. Then I went to the University of New Brunswick on our East Coast. And then I took 5 years off, and I'll talk a little bit more about the work I was doing with our oil sands industry. And then I went to Wilfrid Laurier University, and now I'm at the University of Calgary. So I've popped all across the country several times. Similar to Australia, we've been going through a period of reconciliation with our First Nations that were present prior to European settlement. And there was more than 100 First Nations in Canada before, and it's traditional in our talks to give a territorial acknowledgement that the land I work on in Calgary is the traditional territories of the Blackfoot and the people of Treaty 7, which includes the Siksika, the Pikunai, the Kainai, the Tsuut'ina, the Stoney Nakoda First Nations, including the Chiniki, Bearspaw, and Wesley First Nations. And it's also the home to Métis Nation of Alberta Regions 3 and 6. I don't know why whoever made this picture overlapping Australia and Canada didn't center, but very similar size between Australia and Canada. Canada is about 30% larger, but it's all in the north and it's all ice covered, or traditionally is ice covered. Calgary is somewhere near that little red dot that I put on here. And it's a picture of Calgary. You can see behind us in the background there, the Rocky Mountains. We're about 45 minutes from the Rocky Mountains. The Rocky Mountains generate about 80% of the stream flow in Canada. Most of the river is flowing north. In any river basin, there's 11 different types of monitoring programs that go on. Existing developments, I separate them into 5 types of monitoring: compliance monitoring, crisis and spill management, mitigation effectiveness, environmental effects monitoring, which I'll talk more about, and performance monitoring. Proposed developments have three types of related monitoring. It's like I hit puberty all of a sudden. Cumulative effects assessment, environmental risk assessment, environmental impact assessment, which are closely related but have different monitoring requirements. And then governments have 3 types of regional monitoring: accumulated state monitoring, status and trends I separate those words intentionally because Alberta, where I work now, when they say status and trends, they just mean trends. And a new type of monitoring I'll talk a little bit later, which we call cumulative effects monitoring. The challenge is each one of these monitoring programs reports to a different government department. And there's no common framework, no common philosophy, no common methodology linkage or regulatory basis, and there's no common database. An outline of what I'm going to talk about. Some unique aspects of aquatic monitoring in Canada, environmental effects monitoring and adaptive monitoring, adaptive management and sustainability, cumulative effects assessment, and then Kelly's theory of everything. And at home, this is from a couple of weeks ago with wind chill minus 49, so I'm very happy to be here. So one of the unique things about Canada is we have a Fisheries Act, which is one of our original pieces of legislation from 1867. In 1867, they defined fish quite broadly, included shellfish, lobsters, crabs. But that act says you must protect fish habitat, and man did say man, and use of fish. We changed that now. And up until the late 1980s, it was our only piece of environmental legislation related to our aquatic systems. Canada has a requirement that you have to demonstrate harm. We don't have a best available technology national regulation. And so until the Canadian Environmental Protection Act came in, you had to demonstrate harm. So a lot of emphasis on going out and looking at fish and fish habitat and contaminant levels in fish. We can now regulate individual chemicals if they get on the priority substance list, if they're toxic. But the Fisheries Act is still a dominant piece of legislation. In my postdoc, I looked at fish downstream of a pulp mill on Lake Superior. The top is a white sucker female coming in to spawn. We've opened up her body cavity. You can see the ovaries are nice and full and yellow. At the pulp mill site, they're much smaller. White sucker were 2 to 3 years late in reaching sexual maturity. These are whitefish males just before spawning. There's about a 5-year delay in sexual maturity, and they only lived to be about 12 or 13. And so even though this effluent passed all regulatory requirements, we still saw really dominant effects at small dilutions in the receiving environment. That led to the development of environmental effects monitoring. I helped write the requirements when I was in the government. EEM is a regulated, mandatory, industry-funded cyclical monitoring program to answer whether mills in compliance with their effluent discharge regulations are associated with environmental impacts on fish or benthic invertebrates. We use fish at benthic invertebrate communities as an indicator for fish habitat or fish use. So developed for pulp and paper between 90 and 96, metal mining 95 to 2000. We tried to get one in sewage, municipal waste. It was in the draft reg, it never got into the final reg. Diamond mines came in 2018, and coal mining is targeted for this spring, and oil sands mines are under development. Resources are a provincial responsibility, with the exception when there's a national sector-wide regulation under the Fisheries Act. The feds don't get involved in water regulation in provinces unless it's transboundary. It's an important fisheries. It's on national lands like national parks or indigenous lands. And there's one other case I'll get to in a second. So EEM is an adaptive monitoring system that operates by changing tiers of effort through cycles. So you start with a surveillance cycle. In most cases, they go every 3 years and ask if there are changes. If you see an effect beyond a critical effect size threshold, you go to confirmation. If you confirm that change, the next cycle you go to extended magnitude, and then investigation of cause and investigation of solutions. EEM changed some important aspects of how we approach monitoring. Developed a standardized national approach, standardized indicators and effect sizes. It was adapted and cyclical to focus resources where there's the most concern. Shifts between tiers are automatic. You can accelerate them. It's based on a critical effect size of either a 25% change in the level of the indicator or 2 standard deviations. We had to define when we developed what was not an impact. So for fish, we said, if you can collect 20 adult males and 20 adult females upstream and downstream of the outfall, and we see no differences in how old they are, how fast they grow, how many eggs they have, how big their livers are, or what their condition is, then we're going to assume for now that you don't have a major impact. We had to define power and sample size expectations during study design. And for the stats geeks, we actually said in the regulation that you were required to set type 1 error rates equal to type 2. And it's important to recognize that EEM was not designed to find facility-specific impacts. It was saying this site is in compliance with its regulations. In its discharge, do we still see issues? It could be from something upstream. It could be a cumulative effect. It could be one of a number of things. So it wasn't designed to ask, is the pulp mill still causing problems? This reg really formed the basis for the research throughout my career on monitoring design, how to sample, when to sample, who to sample, where to sample, how many to take, and how big a change is important. 3 major challenges with monitoring. There's more than this, but I'm just going to talk about these 3 briefly. What to use as a reference site, how to define baseline, and how to define ecologically relevant change. That's me in my master's program up there. I look the same still to me. I did my master's in on the western end of Lake Ontario in Hamilton Bay. Hamilton Bay is quite a large bay that's isolated from the rest of the lake by a sand spit. It has a small entry channel between, so very poor flushing. Had two steel mills that employed about 60,000 people, and that their effluent went into the harbor. And if we set nets in the late 70s, I did my master's in a fish cancer lab. There were 3 abundant species of fish, and all 3 had cancer. The top one is a brown bullhead. You can see a papilloma on its lip. It's got a melanoma on its nose. Its barbels have been burnt off by the PAHs. That's a carp gonad tumor in the middle picture, and a liver tumor and a white sucker on the bottom one. So Kelly defines sustainability as the next generation should inherit an environment at least as crappy as the current one. I can't change how we got to that situation. All I can do is try and make sure that the next generation gets an environment at least as good as we have. You don't want the next generation to get 2 species of fish with cancer, but it's not acceptable to have only 3 species when there should be 50. So I separate the issue of sustainability and acceptability. Sustainability is really about looking forward. So restoration is a question of acceptability, and sustainability is related to degradation. And the priority has to be to stop degradation before you consider restoration. The study designs are very different, but what it means is establishing the current recent baseline is critical for monitoring. Any degradation at any level is unsustainable. And so the focus becomes looking for degradation from the current state and then trying to look at issues of acceptability. When I moved out to the University of New Brunswick, we formed the Canadian Rivers Institute. That's a picture of Alan Curry's smiling face from the website. St. John River is on our east coast, It's 650 kilometers long. It starts in the Maine North Woods in the U.S., forms the international border for a little ways, and then ends in the Bay of Fundy. When we formed the Canadian Rivers Institute, we said if your research is not place-based, send your students to work on the St. John River. They can use our boats, they can use our trucks, they can use our equipment, they can share accommodation with our students. And between 99 and 2010, resulted in more than 115 graduate studies on the river, which culminated in our State of the St. John River report. This is just a map of where those studies were. The colors just mean the year they started. We started in the upper basin and worked our way down. The 4 circles are the 4 biggest changes in the basin since the 1960s. There's a rare earth metals mine in Nashwauk here. The potash mines were undergoing a major expansion. The oil refinery at the mouth of the river was doubling its capacity. And the city of St. John was one of 3 cities without secondary sewage treatment, and they were going through an approval process to put in secondary treatment. 115 graduate studies on the river, 4 major EIAs, thousands and thousands of pages long. They didn't use a single piece of data from any of our studies, which was a bit disappointing. Peter Dunker and Lauren Gregg had come out with a paper on the impotence of cumulative effects assessment in Canada. And they said that their main suggestion was fundamental changes. The main theme, E's are really hard for me apparently. The main theme is regional environmental assessment and regional environmental effects frameworks, which might best be interpreted as technical assessment components of regional land use planning processes. So my wife was a regional land use planning director. We were doing a regional environmental assessment. We were using environmental effects frameworks. And so Monique Dubé and I got together with Peter and Lauren and said, why is what we do not what you ask for? And so it was 3 years of intense emotional growth as I was trying to grapple with the fact that everything I'd ever done was useless. And terminology is very important. All effects are cumulative. In Canada, cumulative effects assessment is something very specific during environmental impact assessment. If I want to put in a sewage treatment plant, I look at my options: an aerated lagoon, activated sludge, tertiary treatment, and I model under those different scenarios what the river would look like. And then I decide on a scenario that I want to develop. Cumulative effects assessment is that alternative scenario forecasting. The project thought changed how we think about monitoring. If you go to your physician takes your blood pressure and your cholesterol, and your physician tells you you're healthy if there's an absence of signs that you're sick. So all environmental health assessment for the last 40 or 50 years has been looking for signs of sickness. If you take a 6-month-old to the physician, they don't do blood pressure. They say you're in the 85th percentile of what we would expect for length and weight for that age. And so it's a performance-based assessment. So when we showed Lauren and Peter this graph after showing them hundreds of other things that we had done, they said that's the first useful thing that you've shown us. This is the size of young of the year sculpin. These are sculpin. They're a small fish. They're territorial. Their home range is about 10 meters. The male forms a nest under a rock and guards it. In New Brunswick rivers, they're about 7 per square meter. So to go out and get 100 or 200 of them doesn't take very long. And we knew from all the studies we were doing in New Brunswick that if we went into a river and in the end of August, the start of September, and 70% of what we caught were this year's babies, and the babies were between 25 and 45, that the river was healthy. So under the old human health paradigm, we would say anywhere between 25 and 45 is healthy. If you have a model of what's driving the variability and you know that this year's water was only 17 degrees, you can actually say, I would expect this year's fish to be in this size range. And it changes monitoring from retrospective to predictive. And And that's what we call cumulative effects monitoring, observed minus expected. And so the focus became what drives natural variability. People, when they design monitoring programs, want numbers that are very stable from year to year. If you're doing this model development on what drives variability, you want things that change between good years and bad years. And when we looked at our environmental effects monitoring framework, they'd convinced me it was totally useless. But the things that would be different between a good year and a bad year are how fast a fish grows, how many eggs it has, how big it is when it matures, all the same indicators we used in EEM. I'm going to switch gears a little bit now and talk about Canada's oil sand reserves. I don't know if you have heard much about our oil sands over here. They're a big topic in North America. 170 billion barrels in the deposit, the world's largest oil reserves available for private development. Canada's largest contributor to GHGs, and production just in December exceeded 4 million barrels per day. 2008, 2009, Erin Kelly's postdoc, she worked with David Schindler, went out and surveyed pH levels in the snow and concluded that every spring when the snow melts, there was equivalent of 2 to 3 major oil spills going into the river. Generated enormous attention internationally. The European Union labeled Canadian oil as dirty oil. And the federal government, I mentioned, there's specific things they can get involved in. One reason they can step in is if there's a threat to the national economy. And the oil sands are a major driver of our economy. So the federal government in 2011 said, the province, you've dropped the ball on protecting this resource. We're going to take over. The world is losing confidence. We're going to charge industry $50 million a year to do monitoring that we'll do. So we're going to charge them $50 million a year. I helped design it. They brought 100 scientists together. 5 of us worked on the framework. Purpose was to increase the sites, the level of detail, the confidence the resource could be developed responsibly. And the 2 main components, adaptive monitoring to focus monitoring resources, and what drives the variability so we can increase the sensitivity of monitoring and change from retrospective to predictive. 5 people helped develop the framework. One was Fred Rona. He went to be chief scientist for the new monitoring agency the province created. Monique Dubé went to be the chief scientist for the Alberta Energy Regulator. And I took time off from university to go work with COSIA. COSIA was an alliance of 13 oil sands companies that made up about 95% of the production. When a couple duck kills happened in around 2010, oil sands are over a major migratory bird pathway, and Alberta has enormous hailstorms in the summer, and ducks don't like to be flying in hailstorms. And twice they landed on tailings ponds, and in one case there was unknown, but thousands of ducks died. When it hit the newspapers, they blamed the wrong company. And the companies got together and said, look, this isn't my company against yours. Everybody hates us as one thing. So COSIA was formed, and the companies agreed to share environmental protection patents royalty-free for use in the oil sands across all 13 companies. I went to work as director of monitoring to help them adjust their monitoring to align with the new system. And the first question I did, I had the senior monitoring people from 13 companies. Eventually we were working with 17 companies. And the first question I asked them was, what monitoring do you currently do? And now that you give $50 million a year to the regional monitoring, what do you think should stop? And I was shocked to find out no company could tell me all the monitoring they did. It spread across different facilities and different components responding to different regulations. And there wasn't a line item that said monitoring. It took us 18 months to do a survey. And we figured out they were spending $180 million a year in monitoring across 74 different programs. Nobody was doing anything with the data. They were reporting it to the government. Government insisted it going in hard copy. And if you didn't have a notice of exceedance that went in with it, they didn't even open the envelopes. So the challenge they gave me was to tell them how big a change they should pay attention to, because they were going to start focusing more on their monitoring data. So the oil sands monitoring program, this is from January of 2022. The monitoring program, I guess it's being taped, I have to be careful. Monitoring program has a lot of challenges. And funding, lack of analysis, lack of communication, no strategic plan, lack of coordination. We're now 600 million into monitoring, and there hasn't been any public reporting. Why? Hesitancy of the province to provide transparency, clarity, and public accountability. Difference between the provinces and the feds. There's three philosophies of monitoring: stressor-based monitoring, where you look at all the potential chemicals; effects-based monitoring; and values-based. Province is stressor-based, the feds is effect-based. Complicated governance process, which has changed many times. And a desire of all participants to control the narrative and the interpretation of the data. Again, what we wanted the program to do was define baseline, do adaptive monitoring and what drives variability, and it, for the most part, hasn't done that. There's a fundamental misunderstanding of what adaptive monitoring is. If you look up adaptive management in Google, you get lots of figures like this, and in every one of them, there is a thing called monitor. In adaptive managing, that monitoring is meant to monitor the consequence of a policy change. So if I'm losing my eelgrass beds, then I come in with a policy change and I go out and monitor to see if the eelgrass beds recover. So it's a very focused type of monitoring. I know what the impact was. I know what my management process was. Adaptive monitoring is not adaptive management. So monitoring in the context of adaptive management is an interpretation phase where data is collected on the consequence of a policy or regulatory or management change. Monitoring is focused on the effectiveness of mitigation. Remember, Canada's focus on harm, and that EEM was not focused on a specific facility. It was meant to tell if everyone's doing what they should be doing, do I still have a problem? It's not the purpose of monitoring to manage the environment, but it is the purpose of monitoring to provide the information required to make management decisions. Those decisions require other processes, and monitoring needs to be agnostic to the decision, but you need to make sure monitoring outcomes are actionable. So there's two cycles. There's an adaptive monitoring cycle and an adaptive management cycle, and then a monitoring cycle within adaptive management, which says, did management work? But adaptive monitoring needs to operate quickly. Results from this year need to tell me what I'm going to do next year. Adaptive management is more deliberate. You have to change regional plans, visions, and policies. It operates on a 5 to 20 year time scale. So one of the challenges that we have with our oil sands monitoring is the federal government EEM has tiers and triggers. The regional land use planning in Alberta has tiers and triggers, but they're totally different meanings. And they constantly confuse what they're trying to do. Each of these has a defined monitoring trigger or management trigger, which signals when a change needs to be made. There's additional cycles. There's a modeling cycle. I mentioned we want to understand what drives that variability so we can come up with a forecast trigger. There's additional triggers in the system. Groups doing planning, monitoring, and modeling are linked and can have overlap in people, but the activities, time frame, and outcomes are different. An iterative feedback loop between modeling and monitoring continually improves both. If you find out that this year's data didn't look the way you thought it would, then you look into your model to see if it needs to be developed or whether it's a consequence of a change. An effective cyclical EEM program is the engine to drive the entire program. We know that aquatic systems vary with temperature and flow. I showed earlier the young of the year sculpin ones. This is trout perch, which are a small-bodied sentinel species used in the oil sands. This is at a certain temperature, the impact of discharge on fish size and gonad size, so we can come up with forecast triggers. And then iteratively, you can see here, this only went out this was done based on 2015 data up to 2015. Only went up to 700. We had a year after that where the discharge was 900 cubic meters a second, and it actually predicted negative gonad size. So we have to go back and redo the model, and it's that iterative feedback that improves your model. Almost done. Coupling modeling. Oh, I'm almost done. Coupling modeling. I guess it's O's too. I'm going to lose all my vowels. Coupling modeling and monitoring efforts in an iterative feedback loop. Several important roles in identifying and managing cumulative effects. Developing forecasts to predict future ecological states. Developing forecast triggers to adjust monitoring efforts. And backcasting historical pre-developed baselines when past data are absent or incomplete. Having triggers for monitoring, modeling, management. We also have compliance triggers because the regulator gives you discharge requirements. We have performance triggers because the engineers have given you triggers related to how well your system should be performing. They can all operate automatically, and it brings oil sands $180 million a year of monitoring into a single linked system, which could make automatic decisions. Government hates the approach. This is an example. We've got the different actors, regulators, planners, modelers, regional monitoring, site-specific monitoring, developing, but just go through the developer. He needs from the regulator the compliance limits. He needs from the planner the existing vision and management triggers. He needs from the modeler the existing conceptual model and forecast. He needs from regional monitoring the existing baseline monitoring requirements and sites. He needs to come up with a site-specific monitoring plan and develop a continuous improvement cycle. He needs to provide to the site-specific monitoring, the site-specific issues, the forecast and trajectory. Regional monitoring, he needs to provide the sites to be added to the network and the local forecast. To the modelers, any adjustments to the conceptual model. To the planners, potential changes to the forecast and the future trajectory, and to the regulator, environmental impact assessment and performance. Everybody has a role to play, and working with engineers when I was at COSIA for a while, I'm not an engineer. They taught me about swim lanes, and that's why I've colored regional monitoring, stay in your swim lane. And that's one of the challenges with awesome is people constantly getting out of their swim lane. You guys use that terminology here? So swim lanes are big in our engineering people. Maybe they just played a joke on me. So one of the things we're working on right now is how did Indigenous communities and rights fit into this decision-making process? What would their row and column look like? And how can we integrate it? That's all. I'm happy to take any questions. Just a picture of a few Canadian rivers. Some still snow-covered. So thanks.
I'll run the mic around for any questions that are.
Silence is consensus. If we need to go.
I actually have a nerd mathematical question. I'm very curious, how could you determine the sample size when you're going into the field and running those monitoring tests on the fish?
Yeah.
I'm imagining that's like difficult to define the sample size.
It's a good question. To define sample size, you need 4 pieces of information. You need your alpha level that you're going to use in your statistical test. You need your beta level, which sets the power. You need your standard deviation, so your variability, and you need your critical effect size. And so that's one of the things we did is we predefined a critical effect size. And so when we developed, when we developed EEM, the very first meeting we had with industry, the pulp and paper one was developed independent of stakeholders. And when industry saw it, they went crazy. And an argument broke out at the big meeting with them between myself and another fisheries and ocean scientist about how many fish you had to collect. I said 20, because if you randomly collect, once you're above 16, you've got the standard deviation for the population. And in an iterative process, I just need it to design my next cycle. The other guy said 60. argument broke out in industry, said, if you guys can't agree on the sample size, then why are we doing this? And so there was someone from Ottawa, which is our capital, who knew enough stats to be dangerous, and she said, okay, we won't interpret cycle 1, we'll just get it to collect variability, because once we have variability, we can set sample sizes. So what she committed me to doing was, in the next 5 years, coming up with how big a change we wanted to detect, which was an almost impossible task. And so we came up with, in 1996, we said, everyone accepts there's 2 places in the world where pulp mills have an impact. Gonad size is the most variable indicator. At both sites, they have more than a 25% gonad size. So we want you to find how many sites have an effect at least as big as one where we think there's problems. And then when we got to cycle 3 in 2000, we had enough data from almost 300 studies that we could look at the size distribution, and 25% looked to get the tails of the. And then in 2009, 18 years later, we published a review on critical effect sizes that have been used around the world, and 25% or 2 standard deviations is the most common. So you can come up with an estimate of standard deviation if you get papers that have been published on your endpoints, but yeah, and that was a big change. We forced people to define that. There's another thing that they've never got into using, which is called optimal alpha. We said in the regulation we snuck in the that you had to set type 1 error and type 2 error equal. Normally when you design a study, your alpha is 5%, 0.05. Beta is 0.2, which gives you 80% power. Alpha is the risk to industry. It's the chance of finding effects that was not real. Beta is the risk to the environment. It's the chance of missing an effect that was real. So basically what you're doing is saying, I'm going to accept risk to the environment 4 times higher than risk to industry. And we said, we don't care what you do for power, because industry wants an alpha of 0.00001. If you go out and you say you have an effect at 0.05, there's a 1 in 20 chance you're wrong. They're not going to make a multi-million-dollar decision based on it. So it was one of the big things we did, was stuck that alpha equals beta into the regulation.
We'll move over to Fiona, and then David, I see we've got a question online as well. I'll just go to Fiona first, David, and then hand over to you.
Thanks, Kelly. It was a great talk. I have 2 questions. Let me have 2. The first one is this idea of adaptive monitoring, and if you collect data in 1 year and then you use that to inform what you should collect in the next year, how does that take into account that natural variability that 1 year's got 17-degree extreme temperature?
Yeah, so we've got a number of studies now that we've been doing for more than 30 years, and 25% captures the year-to-year variability in those. That's why we never do anything based on statistical difference. It's got to be a 25% for 2 standard deviations. So that tries to get the noise out of it.
My second question was, where does the community sit in all of this? I guess, in terms of their interpretation of the monitoring data, or their, I guess we've worked on a project where and this is a more site-specific kind of monitoring, but where the species that are monitored are commercially interesting, but not interesting culturally or, for food sources for the people who actually live there. And so they don't trust what, the impacts that they see in the monitoring when they're told it's all fine. And so I guess I didn't really get the sense of, how the community fitted into these government and industry kind of conversations.
Yeah, so one of the challenges when you're using fish is picking which species, and often the ones that communities are interested in aren't the best ones to use for monitoring. And so that's one of the reasons we required 2 species, with the aspiration that you could do one that the community wanted, and then you could do one that made more sense ecologically. But it is a challenge. We've got, right now we're designing a transboundary monitoring program for Alberta and the Northwest Territories. And we're monitoring 6 different species, 5 of them the community picked. And they're really, really insensitive to change. And one that we think is sensitive to change. So yeah. Plus, if you're interested in human health concerns, those species also aren't very good for monitoring ecological health usually because they're top predators, they've got a bigger home range, they're longer lived, and we'd rather have something that was more sedentary and benthic and shorter lived. And so, yeah, there's always arm wrestling. We were told, and we're doing one big study, and they want us to use Arctic grayling, and the first stomach I opened up had 29 hornets in it. Bees. I thought it's not going to tell me anything about the aquatic environment, but.
A couple of questions online. We have David, and I see Eleanor's got one down below. This is David on the screen now.
Okay. Very quickly, Kelly, how long are you around for?
I'm in Australia until March 6th.
And that's here in Sydney?
Oh, I'm here in Sydney until Friday.
Okay, I'd like to sort of try and hook up with you if I could, because there's too many questions for me to ask, but I will throw one in. This work that you're doing looks very, very similar to work that one of our past retired people, not from here, but from Monash, named Barry Hart, who's very well known in the freshwater ecology area, was looking at that. And he was sort of looking at that using a different approach to modelling, which I've got involved in the last 15 years, called Bayesian belief nets, which is a bit different to what I would call frequentist modelling, which is the stuff that you're doing. So have you had any experience with Bayes nets, in particular, bearing in mind one of the gurus of that, Bruce Marcotte, is just over the border in Oregon? Have you come across?
I've certainly seen a lot of stuff. I'd be lying if I said I understood it all. I've seen people who do it. There's been attempts in the oil sands area and in our northern areas to try and use Bayesian networks to align indigenous indicators with Western science indicators. But I haven't had any experience myself in trying to do that.
Yeah, the reason I ask is that I'm involved with something to do with antimicrobial resistance at the moment, and this whole issue of monitoring, management, and modelling all being integrated, literally, is exactly the same thing. So that's what I would love to talk to you if I can.
Sure.
I've sent an email to Fiona and Andrew, so hopefully we can hook up maybe tomorrow or the next day whenever you're free.
Okay, sounds good.
Great, thanks, Kelly.
Online, we've got another question from Eleanor. Just scroll down a little bit.
So, yeah, I haven't had a lot of work. The question, I guess people online can see it, read it here. The frameworks are being used to understand ecosystem restoration and improve knowledge. So the framework I developed hasn't really been implemented anywhere. Industry loves it. I was working at industry when I developed it as a way to try and link their data together. Industry doesn't actually keep any of the data. They spend 180 million a year and consultants collect it. They submit it hard copy to the government. Nobody has all the data in one place. And so I was trying to, and they're starting to now, get them to acknowledge that, you know, in 10 years, that's 1.8 billion in data that has a value. And so some of the companies are now taking an effort to try and centralize their data. But in terms of restoration, I haven't had a lot of experience myself. There's people I work with that do a lot of work in that. But the monitoring frameworks, I mean, they will certainly work to tell you if things are getting better. Looks like we got somebody on the helicopter. Yeah. Dennis, can you hear us?
Yeah, thank you for an excellent talk, and sorry I couldn't attend in person. So we do a little bit of work in PFAS in the WRC, in the Water Research Center at UNSW, and I'd be interested to get your thoughts on it's present in very, very low concentrations, and you know we do a lot of work in terms of where it goes in the environment and the physical chemical properties, but linking that to outcomes, that people do that, and it seems fraught with challenges given the limits of.
Oh, he's breaking up. I agree. No, we lost part of your question there.
Sorry, I'm wondering if you can comment on PFAS and being present at low concentrations.
So it's part of the difference I mentioned between the provincial and the federal approach. The federal approach tries to go out and look for effects. We predefine what an effect looks like, and then we try and work. It's not really top down, it's middle out. So trying to build an adverse outcome pathway with something like PFAS, you can get so far up the pathway, but then you run into extrapolation challenges. In the oil sands, we know that pHs are elevated in the water. We know that they're elevated in bile of fish. We know at the higher areas there are increased liver size, but we don't see any impacts on gonad size or growth or condition or anywhere further up. So you can build them if you can find even a molecular response to them. You can start to build an adverse outcome pathway that you can follow to look for signals of change, but trying to link them to a major effect is challenging.
Thanks.
Thank you. I think we have time for one more question.
Thank you so much. So we have done some work at the Water Research Lab about what is the impact of dam structures in fish habitat. And then here in Australia, they have defined, worldwide, they have defined indices and that you can capture frequency. Like it's slightly related with Fiona's question about how do you assess the temporal variation. So they check frequency of the droughts or flood periods. They check duration of those, time of change. So it's like they said, some fishes needs a rapid change in the flow to survive, others need slower, all of that. Have you considered those kind of indices?
I don't think we have the same kind of environmental levels of disturbance for drought and flow. So that's not something we've looked at. But it's going to be hard. I mean, if you've got the amount of variability drives your ability to detect a change. And so if you've got extremely variable environments and extremely variable endpoints, then being able to detect a change becomes really hard.
Thank you very much, Kelly.
Yeah.
That's all the time we have for now. Another round of applause. Thank you very much. We have a room, some of us are involved in other meetings. Earlier, so those of you at meetings are here. Otherwise, please help yourself with food. And I'm sure Kelly's happy for you to share his contact details. Thank you.
Okay. Now for this next meeting, I don't know if they wanted me to give a presentation or anything or.
No, I'm also
Yeah.